Okay, so wires and a wall. In this example, for a climbing wall, a guy wire R is attached 47 feet high on a vertical pole. Okay, so this is the vertical pole, and then here's the top of the wire, and then the bottom of the wire is down there. Added support is provided by another guy wire, S, so that's tied there to the wall or the pole, and then it's also anchored down here at the same spot as the other guy wire. Okay, and it's attached 40 feet above the ground on the same pole. If the wires are attached to the ground 50 feet from the pole, find the angle alpha between the wires. Okay, so this pole back here doesn't really figure into the diagram. It's just the other side of the wall. Okay, but you can see hopefully that you have two right triangles, one with a hypotenuse R and the other right triangle with a hypotenuse S. Okay, we also know the vertical component, like of those triangles, right? And we also know the horizontal component. So those are going to be our opposite and adjacent sides. And so we're going to be using tangent is what we're going to do. Okay, now we have to talk a little bit about the angles, okay? So right here, this little angle right here, that is alpha. That is the angle between the two wires. This larger angle here is beta. It's going from the horizontal up to the R, okay, the R wire. Okay, that's beta. So there's this other little angle right here, whoops, this angle right here. I'm going to call that theta. So that would be the angle between the horizontal, the floor, and S, okay? All right. Now, I can say then beta is equal to alpha plus theta, right? But I'm trying to find what alpha is. It says find the angle alpha. So I'm going to say alpha is equal to beta minus theta. Okay? All right. So hopefully that makes some sense to you. Now, let's look at the triangles. I'll write it down here. So let's look at the big triangle. And this is R, and this is beta, and this is 47, and this is 50. So I can say from that, that's just kind of a separating that big triangle. I can say the tangent of beta is equal to opposite over adjacent, so 47 over 50. And that doesn't simplify. Okay, now I'm going to look at the other triangle. So should have done that one in green. So I'll look at the other triangle, S. So if this is S, this is theta, and this is 40 feet, and this is 50 feet. So the tangent of theta is equal to 40 over 50, but I'm going to simplify that to 4 over 5. Okay? All right, so we're going to need that. Now, up here, I'm going to use that information. So I'm trying to find alpha. I'm going to use tangent, and so I'm going to say the tangent of alpha is equal to the tangent of beta minus theta, okay? Well, the tangent of beta minus theta, we have a formula for that. Tangent beta minus tangent theta over 1 plus tangent beta tangent theta, okay? And we know the tangent of beta and we know the tangent of theta, so we can put those in. All right, tangent alpha. Now remember, this isn't alpha, but it's tangent alpha is equal to 47 over 50 minus 4 over 5. You know, I'm going to go back to the 40 over 50. How's that? Get a common denominator right when I need to. Over 1 plus 47 over 50 times, but this time I'll use the reduced fraction. There we go. So hopefully that makes some sense to you, plugging all those numbers in. Okay, so in the numerator, I'm getting 7 over 50. Yeah, that looks right. And in the denominator, let's see, what is that going to be? It's going to be 250 plus, and now I need to know what 4 times 47 is. Okay, 47 times 4, 188 over 250, right? 5 times 50 is 250. Yeah, okay. So then I'm going to do some fraction work here. I'm going to make it 7 over 50 times, I'll put the 250 up here, and then I'm going to add 250, I'm too lazy to do it by hand, plus 188, and I get 438. Okay, now 50 goes into 250 5 times, so that's nice. And now I'm going to have tangent alpha equals 35 over 438. Okay, so hopefully I wrote all my numbers right. Now, what am I trying to do? I'm trying to find alpha. Okay, so we don't know what alpha is. We know what tangent alpha is, but now we're going to use our inverse trigonometric function. So I don't want tangent alpha, I just want alpha. So it's like I'm undoing the tangent part. I'm going to say alpha is equal to the inverse tangent of 35 over 438. Okay, now I'm going to run to my calculator. Now is time for the calculator. I'm going to put it in degree mode. I would want the answer in degrees. I think the book does it in radians and then converts it to degrees, and they could ask for it in radians, but I would go with a degree measurement here. Okay, so make sure my calculator's in degrees. Let me clear it out. I go inverse tangent, and I go 35 divided by 438, and I'm getting approximately 4.5687, and it goes. Okay, so I'm going to say alpha is approximately I'm going to go 2 decimal places, 57 degrees. Okay, so that was pretty fun.